This is our Alaskan Fisheries Showcase by Sarah, Lexi, Brandy, and Mimi. Our showcase will focus on the Alaskan fisheries from 1987 to 2020. The datasets show many different relationships and trends that can be seen in our visualizations. Our showcase will focus on 4 datasets of fish in the Alaskan region, including halibut, herring, sablefish, and salmon. Questions about Alaskan fisheries that we answered with our data. Is there a relationship between salmon and the other 3 fisheries for the wholesale value? Has there been a trend in the population of each fish species over time? Has the net weight of the fish affected wholesale value over time? How has price per pound of each fish changed over time? And how has the net weight of the fish affected the price per pound over time?
You cannot do good data analysis without starting with quality data. We started with general fishery information from the National Oceanic and Atmospheric Agency, which is a major scientific agency of the U.S. Department of Commerce. This agency, which also runs the National Weather Service, is an internationally recognized authority on the areas it covers, and that includes U.S. fisheries. From there, we followed their partnership link to the Alaska Department of Fish and Wildlife website, as fisheries in Alaska are managed jointly between the NOAA and the state of Alaska. The Alaska Department of Fish and Game is a state managed agency that focuses on science and the sustainable management of the animal resources of Alaska and its surrounding waters. They prioritize finding the balance between sustainability, protecting wildlife, and maximizing commercial and recreational fishing and hunting. We chose to look at the commercial fish tonnage and pricing because the recreational fishing cannot be tracked, priced, and measured as thoroughly as the commercial fishing data is. The state uses required landing sites and other in person physical enforcement for taxation and limit enforcement, so they have excellent tracking of this data and make it publicly available. There are already several pre-made tables and graphs with some basic analysis shown on the website, but like many scientific websites, if you get deep into the submenus, they had the raw numbers available in a searchable format, so we were able to download the numbers in Excel tables and run our own different analyses. The data we took from the Alaska Department of Fish and Game Commercial Fishing Division originally was in 4 different spreadsheets, and they covered the years 1984 to 2020. Each of these spreadsheets had 5 different attributes per table. These attributes were the year, the species, the process code, the company count, the net weight, and the wholesale value. Um, the year is self explanatory, as is the species. The process code referred to how the fish was processed, such as fresh, frozen. With salmon, roe was one of the options. The company count refers to the different companies, and then the net weight and wholesale value are also self explanatory. We did not need all of these, so that was one of the that was part of the pre-processing that we needed to do, which was eliminating unnecessary information. Another thing we needed to do to pre-process our data was to deal with the null values. And one more thing we needed to do was aggregate all this information.
In the first visualization, we are looking at net weight of fish over time trend line. It shows the total net weight of each of our 4 fish over each year from 1984 to 2020. The trend line for all other fish, herring, sablefish, and halibut, is shown going down while salmon is the only one with a trend line going up. It should be noted for each of the fish, the scale of the y-axis varies, which affects the trend line, so it can't entirely be used for comparison. The second visualization shows the total wholesale value in dollars from 1984 to 2020 of each of the fish, salmon having the highest wholesale value. This bar graph shows the net weight versus the wholesale value. We were unable to change the colors to make the comparison more clear. However, if you look on the x-axis, you can see that the fish are ordered halibut, herring, sablefish, and finally salmon. For each ordered fish, they include the value of total net weight, and next, total wholesale value for each fish. While salmon towers over the values for the other fish, it can be noted that herring is the only fish where its pattern is different, in which its net weight exceeds its wholesale value. This visualization shows the comparison of net weight versus wholesale value over time. Each section for the graph represents a fish with a dual comparison of total net weight and total wholesale value for each year. Time is measured by year from 1984 to 2020. The first graph shows the net weight of herring in pink overlay with the wholesale value in teal. The second shows the net weight of sablefish in light orange overlay with wholesale value in green. The third graph shows the net weight of halibut in pink overlay with the wholesale value in blue. The fourth graph shows the net weight of salmon in yellow overlay with the wholesale value in deep orange. We are able to again see that the weight of herring exceeds its total wholesale value through each passing year. We are also able to see for sablefish, halibut, and salmon, as time passed, wholesale value for all three has increased. The overall net weight for herring, sablefish, and halibut has more so drastically gone down in comparison to salmon. This visualization shows the total net weight of fish over time for the year from 1984 to 2020, with a separate graph representing salmon. At maximum for the graph representing halibut, herring, and sablefish, it reaches over a value of 160 million, while the increment on salmon is much more drastic, standing at over 700 million. Based on the scale, there is great disparity between salmon and the other fish. The demand for salmon is through the roof and increasing their net weight, whereas the net weight for other fish is falling.
For this visualization, we had to create a new derived attribute for dollars per pound of each species. We did this by taking the wholesale value of each fish and dividing it by the net weight. On the x-axis are the years from 1984 to 2020, and on the y-axis are the prices for each fish as dollars per pound. We used the same scale for each chart so that we can compare the prices of each type of fish. Because of this, there is a point on the sablefish chart for 2018 that has been cut off. The value is $15.91 for that year, and we felt it was worth missing that exact point in order to create the consistent scales on the y-axis. We also added a trend line so that we can get a general idea of how the prices are changing over time. By looking at this visual, we can see that the price per pound of each fish has been increasing over time, but sablefish and halibut seem to have steeper slopes than herring and salmon. This visual has dual axes to show the relationship between the price per pound and the net weight of each fish. There is a key on the right side, which is very helpful for determining each area on the graph. I have ordered the key so that viewing from the top graph down, the key will show what color is the price, followed by the color for the net weight. The scale for the price per pound is consistent between the graphs. However, the scale for net weight is different for each graph. This is important to keep in mind because we aren't able to make comparisons between the net weight of each fish since the scales are different. However, our purpose for this visual is just to compare the price per pound and net weight of each fish. By looking at each graph, you can see several instances where the net weight or supply is high and the price goes down. In contrast, when the supply goes down, the prices tend to increase. We can assume that this is due to supply and demand, but there are other factors we would need to consider before coming to a final conclusion. We were able to discover a few different things based on our data analysis. First, we noticed a trend in the population of each fish species over time. Herring, sablefish, and halibut populations have been decreasing over time. However, the salmon population has been growing. This could be due to a couple different reasons. One of them could be that they are experiencing episodic collapse and recovery like some other fish species do. It could also be due to overfishing in other parts of the world. However, our data is from Alaska and they are pretty sustainable right now and do not have an overfishing problem. But again, overfishing in other regions could still be a factor in this. We would just need further data analysis to know for sure. And although salmon's wholesale value was the highest, that is just because the salmon population was the highest. There does not appear to be a relationship between the wholesale values of each fish. The price per pound of each fish has been increasing over time, but sablefish and halibut have seen a higher increase. This could just be due to inflation, which happens to a lot of commodities, just prices rising over time, but we don't know for certain. And finally, when the supply of fish is higher, the price tends to go down and vice versa. Again, this could just be a supply and demand issue where when the supply is high, the prices go down, and when the supply is down, the prices go up. Again, we would need further analysis to know for sure. Here are the sources that we used for our research and analysis. Please feel free to leave us any questions you might have or any feedback you'd like to give us. Thank you for watching our presentation.